Morning, everyone, and thank you for being here today. The paper that I'm presenting is titled Towards Early Detection of Suicidal Thoughts in Text, a Text Mining Perspective. So, this is a joint work between the Department of Computing at University Tunku Abdul Rahman and the Department of Data Science and Artificial Intelligence at Sunway University. Now, a little bit of short version of what we actually do. We built a suicide risk text classifier that does not rely on fine tuning a large language model. Instead, it combines three different kinds of linguistic evidence and it stays interpretable. Next, I'll show you how it's performed and just as important where it failed. Here's the route. I'll start with why this problem matters and what social media changed about it. Then the gap we found in the existing literature, then the methods and the dataset, and three features families at the heart of our framework, the results, and finally the ethics of deploying something like this. I'll leave the time for questions at the end. So, why does it matter? Right. Let me start with the scale of the problem. Worldwide, suicide claims more than 720,000 lives every year. Among adult aged 15 and 29, it is the third leading cause of death. Closer to home, the figure on the right is one of them that motivated this study. Between 2019 and 2021, 872 Malaysian youth aged between 15 to 18 died by suicide. Now, 50% of all suicide recorded in that period. That's a lot. The point I want to draw out is this. Suicide is not a single event. It is a spectrum from contemplating to planning to the act itself. Every intervention we know of works earlier on that spectrum rather than later. So the question that drives this work is whether we can detect distress while there is still time to respond. Now, from the private note to the public feed, something structural has changed about where that distress has become visible. Before social media, someone experiencing suicidal thoughts had very limited outlets for expression. Often, the only written trace was a suicide note, which is, by definition, is found often too late. Today, people post their thoughts, emotions, and struggles publicly, and often anonymously. Reddit is one particular place where this has become a space where users talk openly about mental health, depression, as well as suicide. That shift creates both a problem as well as an opening. The problem is that many people hesitate to seek face to face help and turn to online communities rather than certified professional, which is a genuine gap in mental health support system. The opening is that this behavior leaves a textual trace, and text is something natural language processing can learn to read. So, what is the research gap? So, why do we need another detection method? That's because most of the existing one looks at only one signal. The keyword-based approach match surface terms. They miss metaphor, they miss sarcasm, and also indirect phrasing. And they overflag because any post that merely mentions suicide looks the same as one expressing intent. So sentiment only approach capture emotional tone, but negative sentiment is simply not the same thing as risk. A great many negative posts carry no intent at all. And then a single end-to-end deep model do achieve a very, very strong accuracy, but at the cost of expensive fine-tuning and with very, very little visibility into what actually drove a given prediction. Now, our argument here is that these three signals, meaning, emotion, and grammar, should be combined in one model so that you can still inspect it. Now, moving on to our research questions and objective. So this gives us three research questions. First, how effectively are machine learning techniques at detecting suicidal tendency in social media posts at all? Right? The second one is which algorithm actually performed the best when it comes to this particular task. And the third one, which is the applied question, which is what alternative detection routes exist for people who avoid traditional counseling entirely. From those questions, two objectives. One, we want to build a model that detects suicidal tendency in social media posts, intended as a screening aid for mental health professional, not a replacement for them. Number two, strengthening a feature extraction itself by combining semantics, sentiment, and also linguistic signal, so the model can capture deeper context and also more complex emotional expression. We move on to the literature. So what 20 prior study actually tells us when we review them? So we have a table in the paper that summarizes 20 prior studies. Rather than walking through every row, let me give you just three patterns. On data, Kaggle, Reddit, Twitter, and also Weibo dominates the field. Reddit and Twitter are the most common sources of real posts. In terms of model, there is a clear historical arc from SVM to naive Bayes through LSTM and by LSTM. Now firmly into the transformer families of BERT, Roberta, Distilbert, Roberta, and also BART. And on accuracy, reported figures run anywhere from 67% to 99.9%. But look at what sits behind the highest number. That generally comes from heavily fine-tuned transformer on curated Kaggle datasets. They demand serious compute, and the resulting model cannot explain itself very good. Now, very few studies actually fuses semantic, emotional, as well as grammatical evidence, and fewer still reports what each one actually contributes, which brings us to what we do today. In terms of methodology, yeah, we follow the CRISP-DM, which is a cross-industry standard process for data mining, and we frame the problem as a binary classification, whether the post is suicidal, where we label 1, or non-suicidal, where we label 0. Now, two honest notes on the design. Because of compute and time constraint, we use a single stratified train test and split date rather than repeated cross-validation data, which follows a number of prior NLP studies in this space. Yeah. And the reason we're comfortable comparing classifiers on that basis is that the performance trends stay consistent across all 7 features that we configure and we tested. The ranking does not flip when it comes to that. Now, the data is a publicly available Kaggle collection of Reddit posts scraped using push shift API spanning from December 2008 to January 2021. A total of 232,074 posts were recorded, and every record has just two things: the text of the post as well as the binary label. The labeling comes from the source subreddit. Half of the posts are drawn from Reddit of Suicide Watch and labeled suicide. The other half comes from teenagers Reddit and are labeled non-suicide. That gives an exactly balanced class distribution, which matters for how you read the result later. With 50-50 classes, accuracy is a meaningful number, not just an artifact of a dominant majority class. We split 90 to 10 for training and testing in this case. Now, what about our framework? Yeah? Our framework, we have a 3 feature family. Now, this is the core of the paper. We take 3 different views of the same sentence. The first thing that we take is semantic. We use BERT embedding, where 768 dimensional contextual vectors that represents what a post actually mean, rather than which word happens to appear within the post itself. The second is sentiment. Here, we will use a pre-trained Roberta-based model from Hugging Face, Cardiff NLP Twitter Roberta-based sentiment latest. It was trained on 124 million tweets and tuned on tweet eval benchmark, which makes it well matched to short, informal social media text. The third is linguistic. Using Spacey, we extract 17 part of speech features based on the universal dependencies tag set effectively. So the grammatical fingerprints of a post is being recorded. Those 3 are then concatenated into a single feature vector. So when the classifier actually makes a decision, is seeing meaning, emotional tone, as well as the grammatical structure of the same time at the same time. Crucially, all 3 extractors are frozen, where we are not fine-tuning anything from end to end. Then here comes our feature engineering. Briefly, how each of those is actually computed. We're going to discuss about that. Now, on the sentiment side, text is auto-tokenized and truncated, or padded to 512 tokens. Passed through Roberta, which returns logits for 3 sentiment classes. A softmax turns those logits into probabilities, and those scores are appended to the 768 dimension BERT embeddings. When it comes to the linguistic side, Spacey tokenizes and tags each post, and we convert every tag count into a ratio of total tokens. That normalization matters because it means a two-line post and a two-paragraph post are directly comparable. And why would grammar actually carry any signal at all? Because in our data, auxiliary verb and verb tends to mark emotional expression, and interjections can flag urgency or acute distress. So grammar is not just a noise around the content. Yeah. Now, in terms of modeling, two classifiers, we have seven feature configurations. For classification, we deliberately stayed with classification models, classical models, logistic regression, which is linear and interpretable, and handles high dimensional and embedding space well, as well as random forest, which is an ensemble model that can capture nonlinear relationship. We then ran every feature configuration through both each feature on its own, each pair, and all three together. So we have seven configurations with two classifiers. So what is the result? So we have a result here for logistic regression. Let me pull out three things based on this table. First, semantic feature alone are remarkably strong. 0.91 across precision, recall F1 and accuracy. Contextual meaning does most of the heavy lifting here. Now, when it comes to sentiment and linguistic feature on their own, are very weak. F1 of 0.71 and 0.70 for the suicide class. That's not surprising in hindsight, right? Now, indirect emotional cues and informal grammar are very, very hard to read when it comes to isolation. Therefore, the score. Third, and this is the result the paper turns on. When we combine all three, we give the best recall on suicide class 0.92 with an F1 of 0.91 and overall accuracy of 91%. Now, notice that accuracy alone barely moves. Semantic only was already at 91%. The gain is in recall. Mm. In a screening context, that is exactly the metrics you want to move because recall is the fraction of genuinely at-risk posts the model actually catches. The fusion doesn't actually make the model look much better on paper, but it makes it miss a fewer people. Now, what about random forests? Now, the same feature under random forest tells a different story. The best configuration is again all three features combined together with an F1 of 0.86 and accuracy of 86%, respectively, but consistently behind logistic regression. We think there are three reasons why this happened. Number one, dimensionality. We have 768 embedding dimension swarms, 3 sentiment score, and 17 linguistic ratio. So the tree ensemble rarely gets to use them. Number two, the pattern in suicide-related text appears to be closer to linearly separable than we expected. And third, logistic regression is simply more efficient when it comes to higher dimensional sparse space. So the more sophisticated model is not the better model here, which is worth saying out loud because the default assumption usually runs the other way. Now, when we look at the confusion metrics, for the best model, which is logistic regression with all three features family, 21,203 suicidal posts correctly being identified, whereas 21,048 non-suicidal posts is also correctly here. Then there are two error cells, 2,130 false positive post flagged that were not at risk, and 1,968 false negatives. Those two errors are not equivalent. A false positive means that someone gets attention when they did not need to, which has a real cost, but it's a recoverable cost, obviously. A false negative means that someone is at risk, is being passed over. That asymmetry is precisely why we reported recall as our headline metrics rather than accuracy. Now, when we analyze the error, so where does it fail? There are four patterns. Number one, informal writing. The posts that are expressing suicidal tendency frequently lacks proper grammar and a balanced use of nouns, verbs, as also adjectives, which is awkward because that's exactly what our linguistic feature measures. Number two is broken structure. There are incomplete sentences, unusual punctuation, and inconsistent grammar, all of which will degrade the reliability of POS ratio. The third is recovery narratives. Someone writing about past ideation from a place of recovery still uses the vocabulary at risk. And lastly, metaphor and sarcasm where ideation is implied rather than stated. The common thread is that the hardest boundary is not usually emotional versus calm. It is ideation versus discussion. Someone expressing intent versus someone talking about the subject is very, very different, but it is very, very hard to separate. So, to summarize our contribution, number one, yeah, interpretable multi-feature framework that integrates semantic, sentiment, and linguistic evidence in a single pipeline has been built. Number two, we have evidence that feature fusion improves recall without end-to-end fine-tuning, where we show 91% accuracy and 0.92 recall from classical classifier on frozen embeddings. So this is something that worth looking back into. And number three, empirical insights into what each feature family is actually worth across seven configuration and two classifiers. Now, of course, our research has limitation. The limitations are real, and I want to state them very, very plainly here. Okay? So social media content carries demographic bias. Expression will vary between groups, and our model inherits that. So slang and also non-standard typography distort feature extraction. Subtle as well as implicit expression of intent remains very, very difficult for our model to detect. And of course, we still uses a single train and test split data. That maps directly onto our future work. So we need to have broader multi-platform dataset, comparison against further deep learning architectures, careful cross-validations or McNemar tests to assess performance differences formally, and eventually we wanted real-time monitoring to support timely intervention. Now, before I close, this part, yeah, is what I would like to ask you to take away. Okay? The model itself does not replace clinical judgment. Okay? In any real deployment, a prediction is technically a decision support signal that will help train professional to reach a judgment. So we should never treat it as a judgment itself. Number two, false positive cause unnecessary distress to real people. So false negative creates genuine safety risks when there are no professional oversight behind the system. So both failure modes are human, is technically not the statistic itself. So human intervention is not an optional extra here. This belongs inside a supervised workflow as a triage aid. Right? So it was never meant to be a autonomous screener. So human intervention is still a must. Now, to conclude, combining semantic, sentiment, and linguistic feature gives us a lightweight, interpretable, multi-feature NLP framework that reaches 91% accuracy and 0.92 recall on 232,000 Reddit posts. Competitive performance without end-to-end fine-tuning. To put it simple, combining meaning, emotion, and grammar will help to improve both the accuracy and sensitivity, and also support earlier identification of people at risk, alongside the professionals who care for them. That is all for our presentations for today. Thank you.